Okay, this is part 2 of our review of exponential functions. In this video, we will look at creating an exponential function that fits these criteria, and we will do some multiple choice questions. Okay, in number 11, we're supposed to create an exponential function that is vertically compressed and has a range of -5 to infinity. Well, if you look at the model for an exponential function, it looks like this. Alright, we have f of x equals, and then we'll have like a, and then b to the x minus h power plus k. Alright, the a part is the part that controls whether or not there is a vertical compression or vertical stretch. If this a value is bigger than 1, okay, for example, if this was a 3, that would be a vertical stretch by a factor of 3. But if it is less than 1, it has to be not including the negative sign, which would be a reflection, which is a whole nother thing. But, so I guess I should technically say if it's between 0 and 1, like 1/3, for example, then that's going to be a vertical compression. Alright, this would be vertically compressed by a factor of 1/3. So, I'll just leave this 1/3 because now I have a vertical compression like we wanted. Now we want a range that goes from -5 to infinity. Well, if you just can picture, let's look back at a problem that we did. Okay, look at problem number 1, for example. The range of this function was -5 to infinity. Okay, I guess we didn't actually write it down, but the range was -5 to infinity because the range is the y values, and it went from the asymptote up. Alright, it's not a reflection or anything. And for number 2, the range was from 4 to infinity. Alright, see the asymptote. So the asymptote really determines where the range is going to begin. When it's when it's above the asymptote, it's going to be the asymptote to infinity. So looking at this one, this k value determines what the asymptote is. So basically we want that asymptote to be -5, so that will determine what the range is going to be. Okay, so you could these other values don't really matter. Okay, if I have this 1/3 here and the -5 here, in fact, I mean, it has to be -5, but this just had to be something less than 1. Well, between 0 and 1. So an example would be, f of x equals 1/3 times, I don't know, whatever, 2 to the x power minus 5. This would have been a good answer to this question. You had to have a -5. This a value had to be something between 0 and 1. And but this value could be anything, any number. Let's see, how should I say this? It can either be between 0 and 1 or greater than 1. It can't be negative, and it can't be 1, and it can't be 0. Alright, but other than that, it could be whatever you want. This can't be negative. Did I say that? I said between 0 and 1, so that covers that. Okay, that's enough about such a simple problem. Alright, let's move on. So looking at number 12, what is the equation of the horizontal asymptote? Well, easy one. The horizontal asymptote is going to be right there. So y equals -3 is the equation. Okay, so the answer to that one was D. Number 13, what is the range? Well, again, it's all about the horizontal asymptote. We have to be careful to make sure there's no reflection sneaking in there, turning the whole range upside down. But there is no reflection. There's no negative here. So the range is going to go from the asymptote up, just like we talked about for problem number 1. If the asymptote was -5, and as long as there's no reflection, then the range will be -5 to infinity. So on this one, it's going to be, the range will be from 1 to infinity. Okay, so that is A. Okay, yeah, that's all there is to that, so that's A. Alright, number 14. Alright, so we have to simplify this mess. Okay, do I have space to do this? Let's see. Let's zoom in. Anything to the 0 power is 1. So first of all, that's just going to become a 1. But basically that's gone. Anything with a negative exponent, you should move it to the other side of the line. Nothing goes with it though. So the only thing that has a negative exponent is this z to the -2 power. So that thing needs to move up to the top. So this is going to come up here and become z squared. Okay, so I moved it now. So bye-bye, bye-bye. It's up here now. Okay, what else? Note this -3 is not going to move anywhere. It's going to stay up because this is not an exponent. It's just a regular number, so it's not going to move anywhere. So now that we have this, let's sort of condense it down into a simpler fraction. So I've got -3 times 4, so that's -12. Okay, that's gone. So I've got y squared still. Z times z squared is z to the 3rd power. Now down here I've got my 2, and I've got x to the 3rd power, and I've got y. Okay, what now? Well, -12 divided by 2 is -6. So that happened. The x's and the z's, they're not going to change because there are no x's in the numerator and there are no z's in the denominator. So I'm just going to keep my x to the 3rd power, okay, down there, and I'm going to keep my z to the 3rd power right there. The only thing that's going to change now is the y's. Alright, we have y squared and we have y. And when I look at this, in my mind, I'm thinking, okay, y squared over y. Y squared is y times y over y. So one of these y's are going to cancel out. So that's going to leave y in the numerator. Okay, so that's what's happening. Okay, so I'll have y in the numerator. And that is the final answer. So now I've just got to find it among the multiple choices. Okay, I see the -6, y, z to the 3rd power over x to the 3rd power. There it is. Shabam. That's B. Number 15. When you have a negative exponent on a fraction, what I always recommend doing is do the reciprocal and make it positive. So I would do 243 over x to the 5th power. Now that's going to make this a positive 2/5. Alright, now I would do, I would recognize that when I have a fractional power, I've got a power over a root. Okay, so this is the 5th root in the 2nd power. Okay, so I would do the 5th root of 243 over x to the 5th power, and then I would do the 2nd power. Let's see, 243. Let's look at the power table. Okay, the fifth root of 243 is 3. Okay, running out of space quickly. So I'm going to have 3 over. Now the fifth root of x to the fifth power is just x. Alright, because with variables you simply divide, and that would be like 1. So I have 3 over x in there. Okay, but then I'm supposed to square that, because second power. So that's going to give me 9 over x squared. Alright, 9 over x squared, so that's D. Alright, for number 16, we need to find the average rate of change over this interval. Okay, whatever. Rate of change is the slope. So let's deal with that reality. So since we are really looking for the slope, it would be useful to have a table of values. Just a little one. These, when they give us an interval, they are giving us x values. Okay, so that's -1 and this is 4. These are x values. Okay, so we just need to know the y values that go with them. So just plug in these x values. So if I want to know what goes here, x is -1, so that makes this 2 times 2 to the -1 power. I'm just using the function. Okay, so that's 2 times 2 to the -1 power is 1/2. Okay, so 2 times 1/2 is 1. Alright, because that's like 2 over 1, and these, they cancel out. It's 1. Okay, I probably could have gotten that one off the graph as well. Okay, so -1, comma 1. I could have gotten that off the graph. What about 4? Can I get this off the graph, make my life easier? 4. Nope, that one's off the graph. So we got to do it manually. Okay, so that'd be 2 times 2 to the 4th power. 2 to the 4th power is 16, so that's 2 times 16. So that is 32. That's 4 comma 32. So this is our table of values. Okay, now the rate of change, alright, the ROC, alright, that's just the slope, okay, between these 2 points. So the slope, of course, is y minus y over x minus x. Okay, so y minus y, that's 32 minus 1. X minus x, that's 4 minus -1. Let me not gloss over this, alright? A lot of kids, well, students will accidentally just put 4 minus 1. But no, it's 4 minus, and then we have a -1. There's a double negative here. And so to emphasize that, I'm going to show this on another step. So I've got 32 minus 1, but down here, minus a negative is addition. So this is 4 plus 1. So this is going to make 31 over 5, 31 fifths. Alright, this does not reduce, so this is the rate of change. As a decimal, that would be 6.2 exactly, so that's okay. So that was rate of change over that interval. So now we need to evaluate without using a calculator. Well, we've already been sort of doing this. Power over root, man. So 2 is the power, 3 is the root. So this is the same thing as the cube root of 343. Okay, and then second power. So cube root of 343, cube root 343 is 7. So that gives you 7, and then 7 squared is 49. Alright, we have answers off to the side. Nope, not this time. Alright, number 18. Okay, well, there's a lot of ways to look at it, but a negative power, you can think of it as dropping this whole thing down to the denominator. Alright, so this would be like having 1 over 64 to the 3 over 2 power. Okay, I also could have looked at it as doing the reciprocal and making it a positive 3 over 2. But that's really the same thing, because if I do the 3 over 2 power to 1, it's just going to stay 1. And then if I do 3 over 2 to 64, well, that's what I'm doing. Alright, anyway, again, power over root. So the root is 2, square root. So I've got the square root of 64. And then the power is 3. The square root of 64 is 8. And then so I've got 8 to the third power. 8 to the third power, I don't know that one. 512. So that's going to be 1 over 512. Alright, same type of thing here. We have to just be careful what we do with this negative sign. But first of all, this negative sign, again, a negative exponent, you can think of it as dropping you down to the denominator. So this is going to be 1 over negative 64 to the positive 2/3 power. And again, we have power over root. So this is going to be the same thing as 1 over, alright, that's cube root. So we're doing the cube root of negative 64. And then 2 is the power. So we're going to wind up squaring that. Okay, now the cube root of 64 is 4. So the cube root of negative 64 will be negative 4. There's no problem taking an odd root. It'll just simply be a negative number. If it had been an even root, we would have said no solution. So anyway, picking up over here, I've got 1 over, so the cube root of 64 was negative 4. And then we're supposed to square that. Well, if you raise a negative number to an even power, it turns into a positive. So this is going to be 16, positive 16. So the final answer is 1/16, positive. Number 20, is the following sequence geometric? If so, find the common ratio, write an explicit rule for the nth term, and find the 8th term. If not, explain why. Well, first of all, if it's going to be geometric, there has to be a common ratio. And we're supposed to find that anyway. So the way you find the common ratio is you would take each term and divide by the previous term. Okay, so if I do that using these two, okay, I'll call that R1. So I've got 12 divided by 2. So that's going to be 6. Okay, so that's a, that's a ratio of 6. I guess I will just do it right here. If I do these two, that's 72 divided by 12. Okay, and you know what this is. That is also going to be 6. Okay, so far so good. Okay, now what about these two? If I do 432 divided by 72. Oh look, 6 again. Okay, so because we're getting 6 every time for all the data that we have, then that's why this is geometric. If one of these had been different, then we would have said no, it's not geometric. And also we just found the common ratio, which is 6. Now, the model for an exponential function, if we have a geometric sequence, I'm saying exponential because I know that a geometric sequence is modeled by an exponential function. The rule would look like this. The nth term is going to equal the first term times the common ratio to the n minus 1 power. Alright, that's the general model. So we just found r was 6, so we could go ahead and put that in. A1 is simply the first term, which is 2. Okay, so that's the rule right there. Now I could use this rule to find the 8th term. Alright, so the 8th term would be A8. And again, using the model, that's going to be 2 times 6 to the 8 minus 1 power. Alright, I'm just plugging in 8 for n to find the 8th term. Okay, so that's going to be 2 times 6 to the 7th power. Now, the 7th power is off of the chart. Okay, so it will be helpful. I'm going to do this off to the side. 6 to the 7th power is the same thing as, for example, 6 to the 3rd power times 6 to the 4th power. Whoa, 6 to the 4th power. These are on the chart. So 6 to the 3rd power is 216. Okay. And 6 to the 4th power, 6 to the 4th power is 1,296. Okay, so if I multiply these together, I get this number, 279,936. Okay, so that is 6 to the 7th power. Alright, so the 8th term is going to be 2 times that. Alright, so it'll be 2 times 279,936. So I'm just going to go times 2. So that is the final answer, 559,872. 559,872. Okay, that is the 8th term. Okay, and of course that came from doing 2 times 6 to the 7th power. Alright. Alright, last but not least, the bonus. Solving this equation. Now, so to solve this equation, we are going to have to square both sides, right? Because we need to get rid of this radical. So if I go squaring both sides of the equation, got to be real careful. On this side, the radical will go away just like we want. So we'll have x plus 5 equals. Now on this side, you got to be careful. Remember, I can't just do x squared plus 9. That would be wrong. I have to do x plus 3 times x plus 3. So I'm going to have to double distribute or FOIL or whatever you want to call it. So I'm going to have x plus 5. But over here I'm doing, I've got x squared plus 3x. And then I've got plus 3x plus 9. So that's x plus 5 is equal to x squared plus 6x plus 9. Now I see that it's quadratic, and I have the square term and the x term. So I'm going to need to get 0 on one side and try to factor, or maybe even use the quadratic formula. I mean, how much of a bonus is this? How hard can it get? Could get pretty hard. So let's subtract x from both sides. And you know what, I'm just going to do this at the same time. Subtract 5 from both sides. So that is going to give me 0 equals x squared plus 5x plus 4. Okay, let's see if this is factorable. X squared is x times x. Alright, 4. I'm thinking 4 times 1, alright, because I'm trying to get the middle. Inner plus outer equals middle. Right now I have inner of 4x and an outer of 1x. So if I just leave them positive, that'll give me the 5 that I need, and it'll give me a positive 4. So that's how you factor this. Now to get the final answers, I set these two equal to 0. So if I do x plus 4 equals 0, and I set x plus 1 equal to 0, subtracting 4 from both sides and subtracting 1 from both sides, that's going to give me x equals negative 4 and x equals negative 1. Okay? Now, we just have to make sure that both of these solutions actually work when you plug them back in. Okay? Because sometimes one or both of these are extraneous, meaning they don't actually work when you plug it back in. So I'm going to do my check here in green. If I do the negative 4, okay, so this is my check. If I do the negative 4, then that's going to give me negative 4 plus 5 is equal to negative 4 plus 3. Alright, I can already see this is not going to work. Alright, because I have a radical and I see this is about to be negative over here. So over here I'm going to get that negative 1. It really doesn't matter what this is. So I've got the square root of 1. So that gives me 1 equals negative 1. What? No. So this is false. False. Okay, that means the negative 4 did not work. So that one's extraneous. Cross that out. Okay, let's do another check. Alright, here's the check of negative 1. Okay, so that would be the square root of negative 1 plus 5 is equal to negative 1 plus 3. Okay, again, I'm just plugging negative 1 back into the original equation. Okay, so this one is looking more promising because this time I'm not getting a negative over here, which was the problem on this one. So that's going to make 2, which is fine. And then that's going to make the square root of 4. And the square root of 4 is 2. So 2 does equal 2. Okay, that's true. Alright, so that one is okay. So x equals negative 1 is our one and only solution. And that is it for this video. I hope it was helpful, and I will see you on the next video.